Okay, so now we are going to move into a slightly more complicated version of the half reactions that we saw in the previous video, right? So what happens when we start to add other elements into this thing? So we're going to do an example and we'll go through each step and then I'll set you guys free on your on the worksheets and you can kind of practice all that other good stuff that's going to be on there. Okay, so let's look at the following reaction. Let's look at this reaction. Here we go. Manganese O4 plus C2O4 2 minus. And this is going to make manganese 2 plus CO2. So now balancing this reaction, we're going to have to balance not only the charges, but also all of the elements in there because we have different numbers of oxygens on each side. We have oxygen in two different reactants, all this other kind of fun stuff, right? But the first step, always the first step, step one, is to write out the half reactions. So to write the half reaction, we focus on whatever manganese in this case, right? So I'm going to find everything that's got manganese in it. That's going to be one of my half reactions. So I have manganese O4 minus on this side, and I have manganese 2 plus on this side. That's one of my half reactions. It doesn't matter if it's the oxidation or the reduction. We'll worry about that in a little bit. But now we can look at, okay, what's the next one? The next is carbon. So I've got carbon in compounds on both sides. So I have C2O4 2 minus, and that goes to CO2. And that's it. I've got all my things, all of my compounds, all my reactants, and all my products accounted for. So in this case, we've got two half reactions again, right? One of them is going to be the oxidation, one of them is going to be the reduction. I don't really care which one is which at this point, right? So now step two is to balance the half reactions. Okay. I'm going to start with the carbon one because it's easier. I'm going to first balance the amount of carbon. So I've got 2 carbons on the reactant side. I've got 1 carbon on the product side. So the first thing I'm going to do is balance the carbon. And I do that by putting a 2 here, right? So C2O4, now I've got 2 carbons on both sides. The next thing I'm going to do is balance the oxygens. Right? Oxygens will always come after whatever else is over there. We'll see that over here too. Right? So first carbon, next oxygen. We got 4 oxygens on this side, and we've already got 4 oxygens on this side because we got 2 CO2s. So carbon is balanced, oxygen is balanced. There's nothing else to balance. So the only thing left is to balance charge. Right? And we do that by adding electrons to the appropriate side. So in this case, we have 2 minus on the reactant side, and we have a neutral compound on the product side. And so overall, we need to add 2 minus to the product side. So I add 2 electrons, and now my charge is balanced. So now I have a balanced half reaction. I have 2 carbons on each side, I have 4 oxygens on each side, and I have 2 negative on each side. So that was pretty straightforward. It's pretty simple. We've seen stuff like that before. Let's do the same thing for the manganese reaction. First, we're going to balance the manganese. That was easy. That's done. We have 1 manganese on each side of the reaction, so no worries there. Next, we need to balance the oxygen. So we got 4 oxygens on this side. We have no oxygens anywhere on this side, so we can't just change a stoichiometric coefficient here. We actually have to add oxygen to our reaction. And the way that we do that is we want to add something that's not going to react in a reduction or an oxidation. And so we're going to add water. And specifically, we're going to add 4 molecules of water because we need 4 oxygens, right? So now our oxygen is balanced. So we got manganese balanced, we've got oxygen balanced, everything's good on the reactant side. We got manganese balanced, we got oxygen balanced, but we have now 8 hydrogens on the product side that we didn't have on the reactant side. So now we need to balance hydrogens. And we're going to do this by just adding H+, right? So we're going to add 8 hydrogens to this side. And now I've got everything balanced. I've got manganese balanced, oxygen balanced, and now I've got 8 hydrogens on both sides. Everything is good. All my elements are balanced. The only thing left to balance is charge. Okay, so we balance charge by adding electrons. So first we have to figure out what our charge is. The product side, we just have +2 and a neutral compound, so our product side is +2. So our products are +2. And the reactant side, we've got 8 hydrogens that are all +1, and we got 1 manganese that's -1. So we have +8, -1, we have +7 on this side. So now we're going to add electrons to the reactant side. We're going to add 5 electrons to the reactant side to balance this out, right? So we have -5, now we got +2 on one side, +2 on the other side. Everything is good. Notice that I added electrons to the reactant side in this one, and I added electrons to the product side in my other half reaction. So once again, we have 1 reduction and 1 oxidation, right? Reduction is gaining electrons, so the manganese is being reduced, and oxidation is losing electrons, so the carbon is being oxidized, right? So this one is our reduction because the electrons are on the reactant side, and this is our oxidation because the electrons are on the product side. Now, step 3, same number of electrons on each side. So now I have 5 electrons on my reactant side, I have 2 electrons on my product side. I need to even those out. So I'm going to take the reduction and multiply everything by 2. Right, so now I get 10 electrons plus 16 H pluses plus 2 manganese, oops, O4 minus. And then on the product side, I have 2 manganese 2 pluses and 8 H2Os. For my oxidation, I need to get to 10 electrons on the product side, so I'm going to multiply everything through by 5. And so I have 5 C2O4 2 minus goes to 10 CO2 plus 10 electrons. Now to get back to my final balanced equation, I just have to add these reactions together. And so what I get is 16 H plus 2 manganese O4 minuses plus 5 C2O4 2 minus. And all of that equals 2 manganese 2 plus 10 CO2 plus 8 H2O. Okay, this is my final balanced equation. And then 4 is add half reactions. Okay. Now, you may be noticing that I didn't include the electrons after I added my half reactions, and that's because I have 10 electrons on the product side, I have 10 electrons on the starting material side, and so those balance each other out, and they don't need to be included. Right, so I have 16 H plus 2 MnO4 minus plus 5 C2O4 2 minus, and that goes to 2 manganese 2 plus 10 CO2s and 8 H2Os. And if we add up the charges here, we're going to end up with 16 plus and then 2 minus and 10 minus, so overall that's 4 plus on this side. And on this side we have 2 pluses and 2 neutral compounds, so this is also going to be 4 plus. So we've managed to balance the charge as well as balancing each element, right? If we go through and add up the manganese, we got 2 manganese, 2 manganese. If we add up the oxygens, we got 8 oxygens plus 20 oxygens, we got 28 oxygens here. We've got 20 oxygens in CO2 and 8 oxygens in H2O, so we got 28 oxygens there. 16 hydrogens in H2O, 16 hydrogens on this side as well, and 10 carbons on each. So all the elements are balanced, all the charges are balanced. This is how we get to our final balanced equation, right? So a little bit more tricky once you start introducing additional oxygens in there. But we can handle that because we just add water and then we add H plus to kind of balance that out. The next video, and I think that we'll probably save this one for a little bit further down the line, the next video will be what happens if we do this under basic conditions, right? And basically what you're going to do is you're just going to add OH minus instead of H2O. So it's pretty straightforward, but we'll get to that. We'll do a separate video where we talk about that. But definitely try out the worksheets that are there. Anything under acidic conditions, you're going to be adding H plus to balance things out, and then and just balance a whole bunch of half reactions. Practice writing those half reactions. Practice balancing them. Practice multiplying them together to get right, and multiplying and then adding them together to get to final balanced equations. And that'll be a good skill to have for when we start to do more things with these redox reactions.